Okay, Bismillahirrahmanirrahim. Today we're gonna do 2.11, section 2.11, where we have to find where the function is increasing or decreasing. Okay, we're gonna start off with function of x equals to x plus 2 over x minus 3. Now the first thing that we have to do is to find the domain of the function. Now if you look at this function, you can see that it has a denominator, and we know that the denominator cannot be 0. So the domain will be all real numbers except x equals to 3. The next thing you need to do is to draw the number line. The number line is actually the x-axis of the function. So because it's all real numbers, x can be from minus infinity to infinity, except x equals to 3. And this is where we know that there is an asymptote. Okay. Now since we want to find whether the function is decreasing or increasing, we have to differentiate the function once. Okay? So f of x equals to x plus 2 over x minus 3. Now because this is a quotient function, we have to differentiate using the quotient rule, and that is f prime of x equals to x minus 3. Then differentiate the numerator minus x plus 2, differentiate the denominator all over x minus 3 squared. Now, so let's solve that. X minus 3 minus x minus 2 over x minus 3 squared, and you will get minus 5 over x minus 3 squared. Okay, and the next thing, d, we're going to look for where the function is, where the slope is 0 and where the slope is undefined, right? So f prime of x equals to 0 and f prime of x is undefined. So here we have to take the numerator equals to 0, minus 5 equals to 0, which is impossible. So we cannot find any x values that makes the function 0, that makes the slope function 0. Next thing we have to get the denominator, set equals to 0. Don't worry about the square. This whole thing will be 0 when the inside of the bracket is 0. So just bring down the bracket and set equals to 0 for x equals to 3. Alright, from D, you see that there is a point that we get where the slope is undefined, which is at x equals to 3. So we're going to bring this 3 to the number line. Going to bring it to the number line, which is here. And you're going to see that it overlaps with the 3 that we have here, which is an asymptote. Okay? Right. So next move on to E. Let me wipe this off. For E, the number line that we had just now was minus infinity, infinity, and then we have a 3 here. From the number line, we see that we have 2 intervals. Yeah, 2 intervals from minus infinity to 3. Another one is from 3 to infinity. So I'm going to put down the interval here. Interval, test point, and f prime of x. It's not fx, but it's f prime, because we want to determine the slope of each interval. Okay, so f prime of x, because we're doing increasing or decreasing, we have to use f prime. So what is f prime of x? F prime of x is minus 5 over x minus 3 squared. Then interval that we get is minus infinity to 3. And the next one is from 3 to infinity. What is a test point? A test point is a point that you pick from the interval minus infinity to 3. So you can take 2, you can take 1, you can take 0, or minus 4, minus 100. It is up to you. But I will take the easiest one. From minus infinity to 3, I know 0 is in the interval, and 0 makes my calculation easier. So I'm going to take x equals to 0 as my test point. And then I'm going to substitute 0 into the f prime slope, the slope function. Alright, so I don't have an x here, but I have a minus 5. So I know that I have a minus value on top. Then when I put 0 here, we have 0 minus 3. So minus 3 is 0 minus 3 is minus 3. When you square it, it becomes a positive. So minus over positive is negative. Now what does this tell us? It tells us that from the interval minus infinity to 3, the slope is negative. If the slope is negative, the graph is going downwards. Okay? It's going downwards from where to where? Minus infinity to 3. So what do? You draw a straight line, or a line that goes down like this. And since there is an asymptote, you know that it does not cross the asymptote, so we just turn it like that a little bit. So here we can see the function is going down. And when you read a graph, you read a graph from the left to the right. And you can see from here, from the left to the right, the graph is going down. Then we go to the next interval. We take x equals to 4. You can take 5, you can take 100, you can take 2000. But I'm taking the easiest point so that it's easy for me to calculate. And I put it inside the slope function. The numerator has a minus 5, so it's a minus value. When x equals to 4, 4 minus 3 is 1. 1 squared is positive. So minus and positive is a minus. Again, I can see here that from 3 to infinity, the slope is negative. Slope negative means that the function is going down. So if I draw that on my number line, it looks like this. It's going down. I can stretch it down here because this is not a asymptote. It can cross down. But it cannot cross this asymptote, so probably it goes like this. Alright? So what can you calculate from here? The question is asking where the function is increasing or decreasing. What we have is not the real graph. We are just trying to find where it is increasing or decreasing. So from the graph, from the number line, you can see that the function is decreasing from minus infinity to 3 and 3 to infinity. So increasing, none. Okay. All right. That's all. So let's try another function. Find whether the function is increasing or decreasing. Number 2. Bismillahirrahmanirrahim. So we go on to the next one. We have the function 9 over x plus x. So we're going to find the domain. You can see here in the function we have two terms. One is 9 over x plus x. And this x, any value that you're going to substitute into the function, it has to go to this x and this x. If you look at this x can be any number. But this term is 9 over x. And it is undefined when this x is 0. So what can you say here about the domain? The domain is all real except x equals to 0. Okay, so we draw a number line. That says that the domain is all real, meaning that x values can be any number from minus infinity to infinity. So we have a minus infinity to infinity, except x is 0. So this is where we know that there is an asymptote, where the graph cannot cross that line. Okay? Okay, now, so the next thing we need to do is find whether the function is increasing or decreasing. Alright, so if we want to know whether it's increasing or decreasing, we have to find the slope function. And slope function is f prime of x. So we have f over x over 9 over x plus x, which is the same as 9x minus 1 plus x. So differentiate that, we're going to get minus 9x minus 2 plus 1. Okay, and this is change to the standard form, minus x squared plus 1. Get a common denominator, x squared here, minus 9 plus x squared. This is a quotient form, I call it quotient form. Okay, why we change it to quotient form? Because it's easier for us to extract the numerator from the denominator for the next step. D, find where the slope is 0 and slope is undefined. Slope is undefined. Okay, slope is 0. Here we have to have the numerator equals to 0. Minus 9 plus x squared equals to 0. So x squared so x squared equals to 9, x equals to 3, x equals to minus 3. And then here undefined, we choose the denominator equals to 0, x squared equals to 0, x equals to 0. So how many values do we have here? We have x equals to 3, x equals to minus 3, and x equals to 0. So all these numbers, all these values have to go to the number line. So I'm going to copy them up to the number line. So we have a minus 3 here, 3 here, and a 0 there. Okay, bring it to this number line. Right, so what is the next thing to do? So I'm going to put the E here. Okay, E. So we have to get intervals. So from here, what can we see? There are 1, 2, 3, 4. 4 intervals. Minus infinity to minus 3 is one interval. Minus 3 to 0 is another interval. 0 to 3 is another interval. 3 to infinity. So there are 4 intervals altogether. So we have the interval here. Interval. We have the test point we have the f prime, not f double prime, yeah, f prime of x for increasing, decreasing. And f prime was minus 9 plus x squared over x squared, right? Okay. So intervals was minus infinity to minus 3, minus 3 to 0, 0 to 3, 3 to infinity. So we take a test point. X equals to minus 4, x equals to minus 1 here, x equals to 1, and x equals to 4 here. Substitute inside f prime. Minus 9 plus 16. Minus 9 plus 16 is positive. Squared is positive, so positive, positive. This tells us that the function is going up. From where to where? From minus infinity to minus 3, the function goes up. So you draw minus infinity to 3, it goes up like that. Okay? And then minus 3 to 0, minus 1. Minus 9 minus 1 is minus 10. Minus 10 is negative. Bawah is, in the bottom is positive, so this is negative. Negative tells us that the function is going down. So going down from minus 3 to 0. Right. From here, from minus 3 to 0, it goes down. And it is continuous. Yeah, continuous. It's not, we don't have an asymptote here, so it joins. And then it goes down all the way. And this is an asymptote. Asymptote does not cross the line. Okay. And then we have 0 to 3. Take one test point, x equals to 1. So minus 1 plus 1 is minus 8. It's a negative sign over positive. Negative means the function is going down from 0 to 3. So we cannot connect this line with the line from here to here because there is an asymptote here. An asymptote means that the function cannot cross. So we just just take one line, draw a line from 0 to 3 that goes down, like that. Okay. 3 to infinity, we have test point 4. So minus 9 plus 16, 4 squared is 16, minus 9 plus 16 is positive. So we have positive here and positive here, so positive and positive is positive. Tells us that the function is going up. So going up from where to where? From 3 to infinity, the function is going up. So you go to the number line, 3 to infinity goes up. Yeah, can you see that? So what can you say from here? The question is asking, where is the function increasing? Where is the function decreasing? You can say that the function is increasing from minus infinity to minus 3 and also from 3 to infinity. The function is decreasing from minus 3 to 0 and decreasing from 0 to 3. So write down your conclusion here. F, decreasing from minus 3 to 0 and 0 to 3, increasing from minus infinity to minus 3 and 3 to infinity. Okay, so this is question number 2. We're going to do one more question, which is log function. Okay, log function. Work this off. log function. We have function of x equals to log x plus 1. So this is a log function. So remember, when you find the domain of a log function, the function here cannot be a negative value, cannot be 0. So x plus 1 must be domain x plus 1 must be greater than 0. Now it only holds for log function. Yeah? It holds for, not only holds for log function, but this holds for log function. Greater than 0. So that means that x is greater than minus 1. So when you draw the number line, the x-axis, yes, x-axis is from infinity to infinity, but we want to draw the number line for this particular function, and it starts with a minus 1. So this is number line. So the left of minus 1 does not exist for this function log x plus 1. Okay, the next thing we need to do is to differentiate log x plus 1 to find the slope function. So f prime of x equals to, bring this one down, x plus 1. This is base 10, so we have ln 10. Differentiate x plus 1, get 1. Okay, so we have 1 over x plus 1 bracket ln 10. Okay, and then what do we do? Slope function, set slope function to be 0, slope function to be undefined. Okay, so here we take the numerator equals to 0, then we have the denominator equals to 0. So the numerator here is 1. This is the numerator. This is the denominator. Okay. So 1 equals to 0 is impossible, cannot be. So we don't have any x values that would make the slope to be 0. So for this function, the graph does not have 0 slope. And then we go on to the next one, denominator. So this function has a denominator. It is x plus 1 ln 10 equals to 0. You can ignore the ln 10 because ln 10 is a constant. It will make this whole thing to be 0 when the bracket here is a 0. So we have x plus 1 equals to 0. And that means x equals to minus 1. Okay. So what do you do next? You bring the minus 1 to the number line. So when you put the minus 1 in the number line, it overlaps with the minus 1 that you have here. Okay, so now you can see that how many intervals do we have? There's only one interval. It is minus 1 to infinity. So interval test point f prime of x is 1 over x plus 1 ln 10. Okay, interval here is from minus 1 to infinity. Take a test point. I think 0 would be the easiest. So I put 0 here as my test point. The numerator is a 1, so it's a positive value. 0 plus 1 is 1. Ln 10 is, if you have a calculator, ln 10. Ln 10 is 2.3. 2.3 is positive. So positive. So positive and positive is positive. It means that the function is increasing from where to where? From -1 to infinity. So you can draw a straight line going up. So what does this tell us? And this function doesn't have an asymptote, okay? So your conclusion will be increasing from -1 to infinity, decreasing none.